In this video, we're going to create a function that returns the smallest number of coins needed to make change for the target amount of money. So in this case, we have n, which is our target amount of money, and it's a single non-negative integer representing, like I just said, the target amount of money. And then we have a denoms array, which is an array of positive integers representing coin denominations. If it is impossible to make change for the target amount of money using our array of coin denominations, we're just going to return -1. And before we even get into how we would solve this with code, let's just solve it just by looking at it. What is the minimum number of coins from our coin denominations array to make change for our target amount of money in? So we could go by just guess and check, and we could say, well, let's just take 1 and see how many, and these are, by the way, these are $1, $2, $3 coins, but how many $1 coins would it take to make change for $5? Well, it would take 5 $1 coins. That seems quite high, so we could continue to check. What if we use 2? We could use two $2 coins and one $1 coin, which would be 3 coins. But we could actually solve this by using only 2 coins, and I'm sure you've already guessed it, but we could use one $2 coin and one $3 coin, and that would represent 2 coins, which would be the minimum number of coins necessary to make change for $5. So in order to solve this problem, we're going to use dynamic programming, meaning we are going to build up our solution by first solving solutions to smaller problems. And the way we're going to do this is we are going to build an array of length of the target amount in plus 1, and the indices will represent every dollar amount starting from 0 that are less than or equal to our target amount, meaning we're going to find all the solutions for the minimum number of change necessary, or the minimum number of coins necessary to find change for $0, $1, $2, $3, $4, and $5. So let's write this out. We're going to call this array, we'll just call it nums, and this is one we're creating. This is going to be length of n plus 1, so 0, index 0, 1, 2, 3, 4, and 5. And let's just write it out. 0, 1, 2, 3, 4, and 5. So index 0 will represent $0, index 1 will represent $1, and so on and so forth. What's going to be held in these indices is the minimum number of coins we need to make change for whatever the index is in dollars. So take, for example, index 3 represents $3, and what this index is going to hold is the minimum number of change necessary, or the minimum number of coins necessary to make change for $3. And what we're going to do to solve this is go one coin denomination at a time. So we are first going to assume that we only have access to our first coin denomination, which in this case is 1, and $1. And then we will go to $2 and find how many $2 coins we will need to make change, and so on and so forth until we've iterated throughout our entire denoms array. First of all, we can immediately fill out our first index of 0, because we know that if we have $0, no amount of coins will make $0. So we just write 0 right here. 0 amount of coins will make $0. So now we can start iterating throughout this array and building it out, and we're going to start with our first coin denomination, which is 1. So we start at 0. We have to first check, is 1 less than or equal to 0? And it's not. And we skip this number because no amount of $1 coin denominations will make change for $0. Then we go on to our next index of $1, and we say, is 1, our coin denomination, less than or equal to 1? Well, yes, it is. So that means we can use a $1 coin to get to the target amount of $1. So what we're going to do if that is the case, we take our $1 coin denomination, or we take our $1 target, and we subtract from it our $1 coin denomination, and that's going to leave us with 0. Well, since we subtracted our $1 coin denomination, this represents 1 coin, so 1 coin, plus, and then how many coins necessary or to get to our target of $0. Well, we have already found this, and this is our remainder, but we've already found this, so we can just check back here. The minimum number of coins necessary to make change for $0 is stored here, and it's 0 coins. So plus 0 coins, and this is equal to 1 coin. So we can update this value by just writing 1 coin. So the minimum number of coins necessary to make change for $1 using our $1 coin denomination is 1. So now we move on to our next index of 2, which represents $2, and we check, is our coin denomination of $1 less than or equal to our target value of $2? Well, yes, it is. So what we do is we take our target value of $2 and subtract from it our coin denomination of 1, and that's going to leave us with 1. Sorry about that. And this is our $1 coin denomination is 1 coin, so 1 coin, plus our remainder of 1. We check to see the minimum number of coins necessary to make change for $1, and we have it right here. So 1 coin, and this is equal to 2 coins. So we update the minimum number of coins necessary to make change for $2, which is 2. And since we're on coin denomination of $1, this is relatively straightforward. We're just going to fill this out right here, 3, 4, and 5. And that's how we build our array, at least for the coin denomination of 1. And if we only had $1 coins, these are the minimum number of coins we need to make change for 0, 1, 2, 3, 4, and $5. So let's move on to our second coin denomination, which is $2. So now we're on coin denomination number 2, and we start iterating throughout our nums array, and we say, is 2 less than or equal to 0? Well, no, it's not. So that means that we cannot make change using a $2 coin denomination for $0. And then we check, is 2 less than or equal to 1? No, it's not. Is 2 less than or equal to 2? Well, yes, it is. So that means that we can make change for $2. So we take our $2 target value and subtract from it our $2 coin denomination. That's going to give us 0. So using our $2 coin denomination, that represents 1 coin. And then we add to it how many coins necessary to make change for $0. Well, if we check back to $0, there's 0 coins. 0 coins is equal to 1 coin. We had previously stored that minimum number of coins, or we had previously stated that the minimum number of coins needed to make change for $2 was 2, but we have just done it with 1 coin. So now we need to update that 2 to our new minimum number of coins necessary to make change for $2 to 1 coin. So now we move on to our next index, which is 3, representing $3, using our coin denomination of 2. And we check, is our coin denomination of 2 less than or equal to our target value of $3? Well, yes, it is. So we take our target value of 3 and we subtract from it our coin denomination, and that is equal to 1. So our coin denomination of $2 is 1 coin. So 1 coin plus the minimum number of coins necessary to make change for $1. If we go over here to our index of 1, which represents $1, the minimum number of coins necessary to make change is 1. So we say 1 coin plus 1 coin is equal to 2 coins. And as you can see, we previously stated the minimum number of coins to make change for $3 was 3, but we have just done it with 2 coins. So what we do is we update from 3 coins to 2 coins. So now we move on to index number 4, and we check, is 2 less than or equal to 4? And it is. So we say 4 minus 2 is equal to 2. Our $2 coin denomination is 1 coin, so 1 coin plus the minimum number of coins necessary to make change for $2. Well, if we check $2, the minimum number of coins necessary is 1, so 1 coin plus 1 coin is equal to 2 coins. and 2 coins is less than 4, so we update to our new minimum number of coins necessary to make change for $4, and it's 2. So now we move on to index number 5, and we check to see is 2 less than or equal to 5, and it is, so we say $5 minus our $2 coin denomination, which is 3. $2 coin denomination is 1 coin, plus 3, and we find the minimum number of coins necessary to make change for $3, which is 2. So 1 coin plus 2 coins is equal to 3 coins. And 3 coins is less than the previously minimum number of coins necessary to make change for $5. So we update from 5 to 3 coins. And now that we have iterated throughout this entire array with our $1 coin denomination and our $2 coin denomination, that means that we have the minimum number of coins necessary to make change if we were only given $1 and $2 coins. So let's move on to our final coin denomination of $3 in our denoms array, and then we're going to traverse through our nums array and check, is 3 less than or equal to 0? Well, it's not, so there's no possible way that we can make change for $0. Is 3 less than or equal to 1? No, it's not. Is 3 less than or equal to 2? No, it's not. Is 3 less than or equal to 3? Yes, it is. So that means that we can make change for $3 using a $3 coin denomination. So what we do is we take our target value of 3 and subtract from it our coin denomination of 3. That's going to leave us with 0. Our coin denomination of 3 is 1 coin. And we add to it the minimum number of coins necessary to make change for $0. If we check, it's 0. So this is 1 coin plus 0 coins, which is equal to 1 coin. And then we check, is 1 coin less than or equal to our previous minimum number of coins to make change? And it is, so we update it to 1 coin. And now we move on to index number 4, and we check, is 3 less than or equal to 4? And it is. So 4 minus 3 is equal to 1. Our $3 coin denomination is 1 coin, so 1 coin, plus, what's the minimum number of coins necessary to make change for $1? It's 1, so 1 coin plus 1 coin is equal to 2 coins. And we check to see, is 2 coins less than or equal to the previous minimum number of coins? And it's not. So what we update it with is what it's currently at, too. We don't update it with this. So now we move on to our final index of $5, and we check, is 3 less than or equal to 5? And it is, so we subtract 3 from our target value of 5, and we get 2. Our $3 coin denomination is 1 coin, plus the minimum number of coins necessary to make change for $2. If we check $2, 1 coin, so 1 coin plus 1 coin is equal to 2 coins. And 2 coins is less than 3 coins, so we update it with 2 coins. And now that we have iterated throughout our nums array with every single coin denomination in our denoms array, we have found that the minimum number of coins necessary to make change for $5 is 2 coins. And what we need to do now is we need to make a formula so that we can hard code this out in our code. And it goes like this. It's the same thing we've been doing for all of our problems. So what we do is we iterate throughout our denoms array, and for each denom in our denoms array, what we do is we check to see if, well, it's going to be a nested for loop, because for each denom in our denoms array, we then iterate throughout our nums array. But for each denom with our num, we check to see if our denom is less than or equal to the amount. And the amount is just $0, $1, $2, $3, and so on. So if the denom is less than or equal to the amount, and all this is saying is if each one of these denoms right here in our denoms array is less than or equal to the amount, which we've been doing for each one of these problems, what we're going to do is we can update our array, and we're going to do it like this. So nums of amount, so the current index that we are on in the current iteration, is equal to the minimum of the current index that we are on, so nums of amount, or 1 plus nums of amount minus denom. And if this doesn't make sense to you, we're doing just as we have been doing before. So take for example our last problem. We were on the coin denomination of $3. So we were on the coin denomination of $3, which is right here. And we were on index 5, which represents $5. So index 5, which represents $5. We had to first check if our coin denomination was less than or equal to our target amount of money, which in this case is $5. So we had our coin denomination of $3. We checked if it was less than or equal to $5. It was, so we had to find the minimum number of coins necessary to make change for $5. And we did this by subtracting our coin denomination of $3 from the target amount, which is $5. And we did this right here. And then taking the remainder and finding the minimum amount of coins necessary to make change of that remainder by looking at where we stored it in the past. So the remainder is here. We checked to see what the minimum number of coins necessary to make change for that $2 was, and it was 1. We then added 1 to the minimum number of coins necessary to make change of that remainder because we subtracted our coin denomination of $3 from our target amount representing 1 coin. And if you remember back to every single time we did this, it was 1 coin plus whatever the remainder minimum number of coins was. Okay. We're taking the minimum value of the current index, so right here, the minimum value of the current index, which whatever it is currently, and the minimum coins necessary to make change, because we have to check to see if the new minimum number of coins is less than what we had found using our previous coin denominations. So this is right here, just this right here, 2 coins. So we're taking the minimum value of what it currently was, which was 3, and the minimum value of 2 coins. And in this case, it would be 2 coins, and then we are updating it, that current index that we were on right here, to the minimum of these 2 values. And that's all this is. So in the next section of this coding tutorial, or in the next section of this tutorial, we're going to enter the coding section. So for the coding section of this tutorial, we're going to start out by creating our function, and we're just going to call it min number of coins. This function is going to take in 2 input values, the first being n, which is our target value, and the second one is going to be our denoms array, and that denoms array is going to contain all of our coin denominations. The next thing we need to do is to create our nums array, and we've done this on the whiteboard, but it's going to be of length n plus 1, so we're just going to say float of infinity, because each element is going to be infinity from the get-go. And we're going to do this using list comprehension, so we're just going to say for x in range of n plus 1, because we want this array of length n plus 1. So as of now, our nums array is of length n plus 1, and each element is infinity. From here, we can actually make the very first element equal to 0, and the reason we can do this is because regardless of what our very first or any of our coin denominations are, the minimum number of coins necessary to make change for $0 is 0. So we can just say nums of 0 is equal to 0. And from here, we need to iterate throughout our denoms array. So we're just going to say for denom and denoms. From here, we want to iterate throughout. We want to create a nested for loop, and we want to iterate throughout our nums array because for every coin denomination in our denoms array, we want to traverse our nums array. So for amount in range of length of nums. So for every denomination in our coin denominations array, we're going to traverse our nums array, but for each element that we're traversing through, we need to check if the denomination is less than or equal to the amount. So we're just going to say if denom is less than or equal to the amount. And if it is, we need to update that current element in our nums array. So we're just going to say nums of amount is equal to, and we did this on the whiteboard, but the minimum of the current element or 1 plus the index of our nums array of the amount minus denom. Okay, and from here we can just return nums of n because nums n is our target amount, and after if we're out on our outer for loop, that means we've iterated throughout each one of our denominations. So we can just say return nums of n, but we only want to do this if nums of n does not equal infinity. So if nums of n does not equal float infinity. And the reason we're doing this is because if nums of n does equal infinity, that means that it was impossible to make a change for the target amount using our array of coin denominations. So we'll want to return -1 if it does still equal infinity. So else return -1. And from here we're done. We can print this out. So we can just print our function, so min number of coins. The target amount will be 12,345, and the denoms array that we're going to pass it, we'll just say $1, $5, $10, $25. Let's run it and see if it works. So the minimum number of coins necessary to make change for $12,345 using coin denominations of $1, $5, $10, $25, and $25 is 495. And if you got any value from this tutorial, I would appreciate it if you liked, commented, and subscribed.